Hey everyone. So today we are gonna go through how to build a Gen AI application, and that's gonna be a full stack application. And we're gonna use the rack pattern. It's a traditional rack pattern that we're gonna use, and the knowledge source that we are using is the PDF files. So if you can see in this architecture diagram, so we do have the portal where you can go and upload the documents through the Swagger page. You can simply select the PDF file from your local disk, and w- once your upload is done, it's gonna read the PDF and create the chunks that we can that we will get from the embedding model. And once we have those ready, we'll get those embeddings and we'll save this to a vector DB. In our case, we're gonna use the Chroma DB. So we'll save that DB, and after that, whenever we have a front-end application where users gonna interact with the chat application, that internally interacts with the LLM and the vector DB that we're using. So based on the user query, we'll convert the user query to a vector embeddings. We'll try to do a similarity search with the user query and the embeddings that we have in the vector DB that we saved from the PDF. We'll try to find out the close matching that will give you a idea like the context, in what context we should generate the response for the user. So once we have the once we have the output of similarity search algorithm, we'll get the data back to microservice, and the microservice will create a prompt with the user query context, and it will ask LM to generate the response. So, and in our case, the LLM that we're using is a Llama 3.2. That's a Ollama model that we're using. And once we get the response, we'll send the response back to a user. So let's go through the what are the components we have in this application. The front-end application, and the project name is Chatbot app. We'll go through that. So if you see the chatbot service, that's a microservice that's running here. And this chatbot app is something that's running at the user front end. And then we have Ollama LLM embedding models. So Ollama LLM model is used to generate the response, and the embedding model we are using here to convert this to convert the text to vector embeddings that we can save in the vector DB, and later on, once we have the user query in, we'll use this as a context, of course, after doing a similarity search. So I do have the PDF files already attached to the GitHub, and you should have to make sure you have the Docker installed up and running. And I have the Docker compose file that will make sure all the services are up, starting from front end, microservice, and the LLM models. And then we have some other instruction how to run that, how to upload the PDF document. So all these things are here. And anyway, we'll go through in this video through the demo how to do that. So there's the whole thing, and there is a PDF documents that you can use. I'm using these three documents just for the testing, but you can try the bigger documents and let me know if you see any issues. So we have a config folder. In the config folder, we have a .environment file. In .environment file, you can specify what embedding model you want to use, what LM model you want to use, and like if you want to know the exact name of the model, you can always go to ollama.com, and they have like embedding that you can enter here. So there's a nomic embed text that I'm using here, and LLM model. So you can simply type LLM. It will give you all the LLM models that you can use. So you can use any model from the Ollama, any embedding, any LLM model. You can make sure the names are correct. So this Docker Compose will make sure that all the services are up, and whatever model you're specifying in the environment file is downloaded and up and running. So achieve. So let's go to the demo. So I'm gonna start with the scratch. I'm just gonna clone this whole repository on my local. So let me just copy. Okay, let me get the actual URL. Just for security purpose, I'm not exactly showing you the sign in because this GitHub is not sign in. That's why I'm not getting as such. Uh, thing. Let me try the HTTPS. I haven't tried, so okay. So here we have the terminal. We'll just get make sure get installed, git clone, and we'll save this here. Okay, just want to make sure we're on the current directory. Okay, do we have any folders? Let's create a folder. Uh, let's do the git clone. So it's gonna clone the whole project. So now we have this. Let's open this in the VS Code, and we have the Docker up and running. So let me resize that for you. Yeah, so the no images, the no content, everything is okay. So yeah, we'll just open the terminal and yeah, we have generative AI. Let's go there. And okay, so we might have to change the branch here. Let me get the branch name. Okay, so there's a branch name where I have this demo code available. Rack hyphen based application. Let's check out this branch. So now we are on the, we should see the code. Okay, so now we have the code here. So I just simply have to run docker compose up hyphen build, and that's gonna take around like I would say a minute. So yeah, I'll take a pause there, and once it's done, we'll come back again. Still, it's uh, building and running the all three services. So if you go to Docker Compose, you can see here I have this Ollama chatbot service and chatbot app. So the chatbot is a front-end application, chatbot service is the backend application, and Ollama is the model that's going to serve us with the embedding and the LLM model. So okay, so we can just go through the command, all these things. If you can see here, Ollama, it's downloading the embedding model because it's a 300 MB, and then after that, it's going to download the. So, okay, so embedding model is done. Now it's downloading the LLM model. So let's wait for this to be done. Then only the services are up and running. Meanwhile, we can just go here and check like, okay, so we have the images up and running. So we have created a volume also to store the PDF files within the Docker in the volume. And I'll come to this later on why we are storing the PDF here, the actual file that we are storing. And then we have VectorDB. There's a VectorDB where we're going to save all the embeddings. And there's a Ollama volume where it's going to save the models that's downloading. So yeah, so we have this, these three services are up and running. We can even verify from here also the terminal. You just have to run Docker. Yes. So that shows on what port all these services are running. Okay, so let me go back to that same terminal just to make sure things are up and running. I think it's about to done. So we'll show you that FastAPI is microservice up and running. So it's up and running. Okay, let's go to the browser and open localhost React Native which is running on 800. So you can see that we have option here, update knowledge source. It will open the Swagger page where you can go and upload the documents, and that will make sure it's converted to a embedding stored in the vector DB. In our case, it's Chrome IDB. So we'll just go and click here. Okay, we'll just go to our directory. We have all this content available. So we'll just go to PDF doc, select Indian economy, and we click on execute. You can even go through the VS Code and see it's uh, converting those chunks, text chunks, embeddings. So it's done. If you go here, Docker DB, if you go to volume, vector DB, you can see like you have this data available entry. There's an entry for this particular embedding that we just convert. Now we have that. Now we'll go to the browser again. Back to this Generative, the chat icon. Click on the chat icon. It will open that, and you can simply ask how Indian economy is done. So we'll just click on send, and we can just go here. In the VS Code, we can see it's start processing. It takes like around, I would say, 50 to 30 seconds to process because I'm running it locally. But once if you have a high-end GPU and everything, that I like you should expect a fast response. So let's wait for that output on the browser. Yeah, it takes some time, so should have something. You just go here in the container, you can see it's still running right now. We'll see the output in this container for the Ollama. Since we have another out logs, should expect a response here in the chat application. So like once we have the response here, we're going to see a citation also. This citation is all about what is the source of the document from where it's getting the response. What is the data source that actually it's using? And I'll make sure all this GitHub link thing is there in the description section of YouTube. And just go through that, try at your end, let me know your feedback. Uh, what kind of other Gen AI application you want to look into it, or do you need any help? Or you want some kind of sample application? It should be ready within a week. So yeah, so you can see you have this whole response, and then you have the citation. You can simply click on citation. It will show you the actual document. So this document is coming from the PDF, and if you remember, I, I told you guys like we have this volume for PDF storage. So this is where we are storing this PDF file, and when you click on the citation, it opens that PDF files from that particular location from the Docker volume. So that's all about this RAG-based application. It's a traditional RAG. So the just keep on uh, working on Gen AI and let me know your feedback on that. So the next application that I'm going to work is going to be a same RAG based, but instead of traditional RAG, I'm going to use the graph RAG. It's going to be a like vector DB with the embeddings, basically the vector DB with the graph DB. So that will give you a more context because once you have the embedding, you can through the graph you can traverse the nodes and through the edges, and you can get the more context, and that will give you a more relevant information. So thank you all.